Okay, so this is just what you need to know. The tangent line is always perpendicular to the radius, so I'm going to write that down. The tangent is always perpendicular to the radius. Let me fix that. I'm going to take a picture of it, make it bigger. So if you see this situation in a problem, you need to draw a right angle right here in this corner. This is always 90 degrees. That's the first thing you need to know. Well, you copied that down. I'm getting ready for the next one. Let's see if this works. Okay, the next one. If two tangents go to the same external point, then they are congruent. So we're talking this one and this one. They both go to point N, so from here to here they are congruent, so you add the tick marks if you see that. Okay, those are equal if they go to the same point outside and they are both tangent to the circle. Okay, so that was the second thing. Getting ready to move on to the third. Oops, wrong one. So sorry. I don't know why I did that. Okay, for this picture here, you need to write down several things. First of all, this is called the central angle. The central angle is in the center. Central angle. This here is called the inscribed oops, spelled it wrong. And this here called the arc. So the central angle, I'll highlight it, is here. The arc is here, but the inscribed angle goes all the way to the other side of the circle. That's the inscribed. So what you need to know is that the central angle equals the arc. But the inscribed angle equals 1/2 of the arc. There's a difference. The central angle is in the center of the circle. The inscribed angle is at the edge of the circle. So don't get them mixed up. So if this is 100 degrees, then the arc is also 100 degrees, but this angle at the other end is only 50. That's what that means. And we'll use that on today's assignment. The central angle matches the arc, but the one that's way across from the circle is 50. All right, the next one. This one has two congruent chords. If the chords are congruent, and that's what I'm going to write, then the central angles are congruent. If the chords are congruent, so are the central angles. So I'm going to come in here and do an arc here and an arc here. And then we just have a couple more. Okay, on this one, if the chords are congruent, then the central angles are congruent. And the arcs are congruent. So if this is 50 and 50, then these will be 50 and 50 also. This could be like 6 centimeters for that chord and 6 centimeters for that chord. But basically, it's a perfect match. The angles match, the chords match, the arcs match, if you see those symbols. And then the last one. You're going to write this down. The diameter is a perpendicular bisector. Of the chord. That means this equals this, and this will be a right angle. That's if it's the diameter. So if this is 10 centimeters, this will be 10 centimeters, and there'll be two 90-degree angles. Now we're going to use these theorems to do a whole bunch of problems that have to do with chords and with arcs. Okay, so here's the 9. This is 9-1 and 9-2 put together because 9-1 was kind of short. Oops, I want to do this. Okay, please look at your theorems that you just wrote down. And there's 2 of them that has to do with the tangent lines. Which one would help us find W? Look at your theorems that you just wrote down on your notes. Which one would be more helpful, the tick mark one or the right angles one? You're looking for W. Which one's going to help you more? The fact that these are, how do you, okay, then what do I write down? What do I write down? We're looking for angle W. So what do I write down to figure it out? What do you put in your calculator then? How many degrees are in a quadrilateral? Isn't there always 360 degrees? So 90 plus 90 plus 130 plus W has to equal 360. So go ahead and put it in your calculator. Figure out what W equals. That's what I got. I got 50. Okay, so we used the one that said the tangent is perpendicular to the radius. That's the one we just used to solve for this one. Okay, look at number 2. I'll give you a minute to look at it, see if you can figure out how to find angle X. Angle X is not 90, by the way. What theorem are we going to use? Well, I can't use this theorem. No, because this is a radius. It's perpendicular. This is not a radius. So I can't use this one. You have to do tick mark, tick mark. These are both tick marks. So if those are tick marks, what kind of triangle does this make it? It's isosceles, which means this has to match. So 70 plus 2x equals 180 degrees in a triangle. This is isosceles because this is tick mark, tick mark. If 2 tangents go to the same point, they are congruent. I'm getting 55. Okay, next one. All right, which tangent theorem is going to work? The tick marks or the right angle? Not the tick marks, because that's not tangent. So you put a right angle right here. Can you guys figure out this angle here? It's a linear pair. So that has to be 60. And what's true about a triangle? They all have to add up to 180. So go ahead and figure out what angle Y is. All right, so I got 30 for number 3. Okay, I'm going to give you a few minutes to work with your table for 4. I might walk around and look and see what you got. So go ahead and get started. I'm going to put it on pause, and then I'm going to come around and see what you got.
So those are both 90. The answer is
See if you can figure out number 5 now. You have to look at the tick marks.
On the perimeter post.
How are you supposed to put those together?
Yes.
These are two tangents to the same point O. So they have to match, correct?
Correct.
And this tick mark tells you that it matches that tick mark, so you know this is 13.
Oh, so this is 12.
Yeah, and then now you're close though.
Oh, 6 and 7.
Right, and this has to be 13 for the same theorem. And then they're saying from here to here is 12.
Bless you.
So this is 6, and this is 6. But because these are both tangents to the same point T, this has to be 6. And so does this. So you need to add up all of those numbers to get the perimeter.
13 times 4 is
I'm getting 76 inches from my perimeter. Okay, I have to do 6 with you because you have to draw a picture for 6. Alright, so let's draw the picture. We're drawing a picture from above. If you are a shot put thrower, here's your head. This will be your shoulders. These are your arms. Then you're hanging on to a rope. And at the end of the rope is the shot put. Now, if you've ever seen anyone throw a shot put, what do?
Spin.
They spin around. So we're going to draw a circle that spins around.
Looks like a hanger.
Now, when she releases the ball, what direction will it go?
I don't know. It will go out.
Will it go this way, this way, this way, this way? Which way? They need to know before they release that shot put.
It's gonna go whichever way that she aims.
It's gonna go tangent to the circle. So when she releases the ball, the physics of it is gonna make it go, oops, I wanna go forward one time.
Whoa, that was a good circle.
Yeah, so it's gonna make it go to here. Let me make an arrow on it. It goes this way.
Screws up.
It doesn't matter. It will always be tangent to the circle. When the physics, this is how the physics works. So they have to train for this, and they have to make sure that when they're aiming, that they release it where it's perpendicular to the target. Does that make sense? Because the tangent is always perpendicular to the radius. So what they wanted you to do is draw this picture. The picture is the answer. And we are done with this problem. Okay? So move on, but that was the picture we were supposed to draw. It's a real world application of the one theorem.
Having a great time.
All right, somebody at each table read this problem to your table, please.
Satellite in a geostationary orbit remains above the same point on Earth's surface even as it goes around the satellite has a 30-degree view. What percentage of the equator is on Earth? I guess it's still young.
So
It's 60. It's 60.
you guys, that's step 1. You need to find that angle there. So what theorem is going to help us find that there?
Actually, it's at 3 itself.
Okay, I'm looking at a four-sided quadrilateral. What should I draw in the picture? What should I draw in the picture?
You should draw that those two are the same length.
Okay, is that going to help us?
Yeah.
It's gonna show us that that's gonna be 60, right?
No.
Oh.
So the tick marks aren't helping yet. So what else should we try to draw?
Like outside line, like an arc. Oh.
Um,
90 in the corner.
90 in the corners is correct.
Oh.
Wow.
That is correct. How does it help us, however? Can
It has to equal 360.
Yeah, so you got to figure out what the central angle is. Go ahead, use your calculator and figure out what goes in this box.
150.
All right, so you have 90 plus 90 plus you don't know plus 30 has to equal 360.
But it says what percentage? Like
We're
70%.
getting there. We're getting there. So the central angle is 150.
So 150 divided by 360.
Now, according to the notes, what is the relationship between the arc and the central angle? Are they the same, or is the central angle half of it? Do these match, or is this 150, or is it 300? It's on your notes. They are the same. The middle angle is the same. So the satellite can see 150 degrees of the Earth. What percent? How do you find the percent?
42%.
You divide by 360 times 100. So that's what percent of the Earth it can see. So I'll grab my calculator. And I'll do 150 divided by 360 times 100. And you're going to get very close to 42%. It's 41.666. So let's say that at any time it can approximately see 42% of the Earth's surface. Okay, analyze 17, figure out what's wrong with the picture.
I know it's if A and B are 90, then
Where are your
360.
Right, so this is 90, this is 90, so add this up. 148 plus 36 plus 90 plus 90, and what do you get?
360.
So this should be what?
360.
Right. So the picture is wrong. Okay, now that was a shortened version of section 9.1, and we are doing 9.1 and 9.2 together. So we're going to go into the 9.2 part. Okay, this is a central angle. If this is 65, this central angle is congruent to the arc. So x equals 165 as well. These match. The central angle matches the arc. So the answer is 165 for number 1. Number 2 takes a little bit more work. Somebody give me a theorem that I'm going to use here. Something about the chords. What does the theorem say about the chords?
Chords are congruent, and the central angles are congruent.
If the chords are congruent, not only are the central angles congruent, the arcs are congruent. So if this matches this, then this is 128, and this will be 128.
Doesn't have to equal 360.
Yeah, that's right. So use your calculator and find Z. So if you put this on your calculator, you get 84 degrees is the missing arc. Because these all have to equal 360 altogether. Okay, move on to 3. If the chords match, then the central angles match.
So 70.
Yep. These are all part of a radius, which is going to be a perpendicular bisector. So if this is 8, this will be 8. So that's pretty simple. Okay, go ahead and move on to 5. I'll give you a minute to do 5. I'm going to freeze the screen.
Jake.
Okay, find AC and find angle B. There's AC. It's the arc. What's true about the arc and the central angle? They are the same. But this is the inscribed angle because it goes all the way to the other side of the circle. What's true about the inscribed angle? It's 1/2 of the arc. So what's half of 68? So that's 34 degrees. Okay, 6. Move on to 6. I'll give you some time to work on it. You need to find W, X, and Y.
34 and 6. I heard my name.
All right, what'd you give for W?
Hear it.
What'd you give for W?
W is 115.
It matches the central angle. See these tick marks here and here? If the chords match, so do the arcs.
Isn't X 1?
Yep. Yep, this arc has to match this arc. That's correct. So you need to find Y. Be aware that this is Y also. So you got 115 plus 115 plus Y equals 360.
Y is 65.
Yep. So I'm getting 65 for Y. Okay, moving on. Okay, with your table, figure this one out. Mark up your diagram, figure out the perimeter. Label everything they give you. Okay, if you are stuck, The radius is a perpendicular bisector, so you need to put tick marks. There's a tick mark here and a tick mark here. And there's a tick mark here and a tick mark here. So break it down to 3 and 3 and 4 and 4, and then keep going from there.
Is the answer 27?
So this is what I get when I break it down. I have 4 plus 3 plus 4 plus 3 plus 6. Yep. Keep going with 8. 8 is a good one. Fill them in. What are you guys getting for Y?
82.
Okay, I'm getting different answers. Okay, so does everybody see where I got W and I got X? The central angle matches the arc, so that's where I got W and X. But they're telling me that this is 130, where the blue line is. So I did 130 take away 48, and I got 82 for Y, because these have to match. So then I have 110 plus 82 plus 48 plus Z has to equal the whole circle, which is 360. So throw that in your calculator. If you're done with that, move on to 9. Okay, because you got the 3 tick marks at number 9, these are all the same. X, X, X. So I wrote X plus X plus X plus 72 equals 360. So go ahead and solve for X. Alright, so my pen. So what'd you guys get for X? Wait, what? Did you guys get 96 for X?
Yeah.
That's correct. Okay, so if this is 96, this is 96. And y has to also be 96 because that's the central measure. So at least we got x and y are both 96. Z is a little tougher to see. So what do you notice about this right here? Isn't that a triangle? And isn't the central angle 96? Is this called a radius? Doesn't the radius go from here to here? And this is also a radius. So this makes it an isosceles triangle. So you're going to get 96 plus z equals 180. So go ahead and solve for z. So I'm getting 42. Okay, look at 10. Again, I'm going to freeze the screen, see how much of it you can figure out. Notice you've got parallel lines in this picture. These are parallel. So that means these are corresponding angles. So if this is 66, then this has to be 66. So that's one way to do that. Now this is 180 degrees. Oh, let's see. Hold on. I'll work on y first. This is isosceles. Looks like this. So this is 66. This is a radius and that's a radius. So I know those are the match. So this is 66 and this is 66. So you got to figure out y. So 132 plus y equals 180. So y is 48. So I'm going to come back here and do this. This is 66. This is 48. And all of these have to add to 180. So do 180 minus 48 minus 66, and I'm getting 66 again here. Yep, I'll take it. Which means z is 66. Okay, then we have to do what's wrong with the picture. Anyone figure out 11 yet? What's wrong with the picture? What's your...
37 should be 36.
Close. What's the radius? What's the diameter? If the radius is 18, what should the diameter be? 36. The diameter has to be the longest chord in the circle because it's the widest. It's the longest chord. So if the diameter is the longest chord, there's no way that can be 37. So either this is wrong or the radius is wrong. Okay, the chord cannot equal 37 if the radius is 18. It won't work. What's wrong with 12? Look at your theorems. Doesn't it say that the diameter is a perpendicular bisector of the chord? So what's wrong? Anyone can see what's wrong or not? What's wrong with the picture? It didn't do it. Is this is not the diameter. How do I know? Because the diameter has to go through the center, and it's not going through the center. So that's what's wrong with it. In order for it to be perpendicular bisector, it has to be the diameter, but this is not the diameter. So that's what's wrong with the picture.